Exercise 2, differentiation. Okay, question 1, differentiate function x equals 2x squared plus x from first principles. Now, just pause the video and have a go at this. Right, now, function x equals 2x squared plus x. So clearly we need to find out what function x plus h is. So function x plus h is equal to 2 outside of x plus h all squared plus x plus h. Just replacing the x with x plus h. Removing those brackets, we get 2x squared plus, now this will be 2xh plus times 2, which is 4xh, plus 2h squared plus x plus h. Now, function x plus h minus function x will be, now all we need to do now is to get rid of this one and the x, and we get 4xh plus 2h squared plus h. Now we'll divide through by h, so we'll divide each of these by h, and that gives me 4x plus 2h plus 1. Now the derivative f dash x will be the limit as h goes towards 0 of function x plus h minus function x on h, which is this. And of course, as h goes towards 0, this goes towards 0, and we get 4x plus 1 is the derivative. All right, here's some more to do. So again, just pause the video. All right, question 2, very straightforward one. Just applying the rule. That gives me y dash is equal to, the 3 comes down, 3 times 3 is 9. Take 1 off the power, x squared. 2 comes down, multiplies by the 4. That becomes 8. And that becomes x to the 1, or just x, because when you differentiate a constant, that'll go to 0. The next one, before we can differentiate, we have to change it. Remember, we're not differentiating, we're just changing it to the fractional indice, which is 1/3 plus 6x to the 1/2. So we differentiate that. Third comes down, it becomes x to the minus 2/3, taking 1 away, plus, and this becomes 1/2 times 6 is 3, x to the minus 1/2. And you can leave it in that form. If you wanted to, you could rewrite that as 1 over 3 times the cube root of x squared, now to see that 3, plus 3 over the square root of x. But it's not really necessary, that's okay to leave it like that. All right, number 4. Again, you have to change that into y equals 2x to the minus 3. And when you differentiate that, you're going to get the minus 3 comes down, minus 6x to the, take away 1 from there, you get minus 4. And that could be written as minus 6 over x to the 4th. But again, that's okay to leave it in that form as well. Okay, question 5. Find the equation of the tangent to the curve function x equals 2x cubed plus x plus 1 at x equals -1. Again, just pause the video. All right, Now, clearly what we need to do first is find out what the function value is. So I'll put that in, function minus 1 equals, now be careful with this negative sign, it gives me this plus negative 1 plus 1. Now that's going to give me, now minus 1 cubed is minus 1, times 2 is minus 2, minus 1 plus 1, so the answer is just negative 2. Now we need to differentiate to work out the gradient, so f dash x is equal to, the 3 comes down, becomes 6, take 1 off the power, x squared, and this is just going to be 1, the coefficient of the x. Putting in the negative 1, we're going to get 6 minus 1 squared plus 1, and that's going to give me 7. So the equation of the tangent using y minus y1 equals m outside of x minus x1. That will give me y minus the y value, which is this negative 2, so it becomes plus 2. And the gradient is 7. That's x minus negative 1, so it's x plus 1. So y plus 2 equals 7x plus 7. And the gradient form will be y equals 7x plus 5. Or if you like, in the general form, it's 7x. Take the y across, minus y plus 5 equals 0. Is the equation of the tangent to this curve, right? 2x cubed plus x plus 1.